This is for the potential energy standard, and in this problem we have a 2 kilogram block that is released from rest and it slides down a frictionless surface into a spring. The spring is attached to the wall and the initial height of the block is 0.5 meters above the lowest part of the slide, and the spring constant is 450 Newton meters. So in this problem we have to find the speed of the block when it reaches the height of 0.25 meters above the base of the slide. We have to find the distance that the spring is compressed, and we have to find the height of the block after it hits the spring, going back towards the left. So first we're going to find our velocity, and we're going to use the potential energy of gravity equation, which is mass times gravity times your height. So we have to do this at both where it's initially dropped at 0.5 meters and where we want to find the velocity at, which is 0.25 meters. So we plug that in, and for the first one we get 9.8 joules and the second we get 4.9 joules. We're going to take that information and we're going to use that to find the velocity. So the equation that we're going to use for velocity is k equals 1/2 mv squared. We know that k is also equal to the change in energy. So we're going to find our change in energy by taking 9.8 joules minus 4.9 joules to get 4.9 joules from the potential energy of gravity equations that we found. After we set 4.9 joules equals to 1/2 times the mass times v squared, we multiply by 2 and we get v squared left. Take the square root to get a velocity of 2.21 meters per second. The second part, we're asked to find the spring compression. So we're going to use the equation, the potential energy of the spring is equal to 1/2 times the spring constant s squared. We're looking for s. So the potential energy of the spring is going to be equal to the potential energy that we found for the block at the initial height. So we already found that, so that's going to be 9.8 joules. We're going to set that equal to 1/2 times the spring constant, which they already gave us, which is 450 Newton meters, times s squared. After solving that, we get s to be 0.209 meters, which is how much the spring was compressed. And the last part of the equation is how high does the block go back up after it hits the spring if the spring sends it back towards the left. So this is an easy question, and because there's no friction, we know that the spring is going to shoot the block right back to the initial height of 0.5 meters.